Okay, how to find critical values. So whether you're doing a hypothesis test and you need to look up a critical value based on alpha, or if you're doing confidence intervals and you need the critical value because it's in the formula, right? So how do you find these? Well, if you're doing a Z, a normal distribution, they do have nice little cheat tables like this, but let's see if we can figure this out. So let's look at 95%, and I get 1.96 is what it shows here. So there is an Excel formula, the norm.s.inv. Okay, so in the past you may have used the DIST to actually find probabilities, but this is finding the Z value. And notice it asks for the probability. Well, if I'm doing 95%, I probably put in 95, right? I hit enter, and that looks more like this value, 90. So what's happening? What up? Well, the problem is you have to understand how you read the table. So the table, meaning la, 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 the table is from the left to the Z value. Okay, so think about that. If I want 95%, let's entertain you once again with my drawing skills. We've seen these in the past, how well these go, right? And so if I want 95%, what I'm doing is, this is an interval, right? You have a minus Z and a plus Z, and my confidence, 95%, is in this interval. So the problem, though, is when you read the table, what you're reading is all the way from the bottom up to that Z value. Do you see the problem? So what we have to do, it's going to seem weird, but unless you see this visually, I don't think it makes sense. What we have to do is think about the entire curve adds to what? 100%, right? So let's just put this in decimals. So this piece inside here is 0.95. So what does that leave us with? If I have 1 minus 0.95, that's going to give you 5%, right? Well, we have to put half of it down here and half of it here. So 0.05 divided by 2, 0.025. And then that piece right there, the same thing. So notice if I'm looking at, I don't like that color, if I'm looking at the table, then what I actually have to look up is 0.95 plus that value. So in other words, I'm looking up in the table 0.975. Or if I go back to my wonderful Excel and instead of 95, I put in 975, looky, 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 looky. So to get a 95%, so 95%, what I have to do is take, this value plus 1 minus this value divided by 2. That's what I did, right? So 1 minus that value, and that's where we're getting the 0.975. So what I do is I set up a cell like this, so this way now I can just click on, click on that cell, and now this value I can change to whatever I want. Let's just do the first one, the 70%. Notice I'm getting the 104. I mean, you can certainly move the decimal around to get the exact values, 0.75, and so on. Okay, so let's go back to the 95, and 95 we see is 1.96, and the key to this is understanding. Let's clean this up a little bit. The key to this is understanding these are Z values, right? And so what I've done is I've said this middle is 95%. I got 1.96 for the upper z value. Well, this is minus 1.96. And now if you go to the actual table, and let's get rid of you. If I go to this actual table now, and I look up in the table, within the table, okay, the actual area, I'm not looking at z values here. What I'm looking for is the area closest to 0.0250 or the area closest to 0.9750. And so this is why a lot of times students, when they first learn this, what they'll actually do is they will look up this lower area because it's a little easier, right? So in other words, if you look up, if you look up this area right here, we already said that's this. You just have to remember that you're doing the plus and minus. So you have to be careful when you're reading these. Now, you might say, well, what's up about this 0.90, 1.645? Well, if I go back here to my table, let's first draw this out. So this is 90%. I had some other graphs down there, but we'll just redraw it. So here I'm looking at 90%. So what am I going to look up in the table? 90%. 1 minus that would be 10%. Half goes here, half goes there. So I'm looking up 0.95 for 90%. So if I come over here and I say 0.90, I can see that value, and I can even add a decimal. But why did they put an extra decimal on that one? Well, let's go look. I'm looking up 95. So within this table, I'm looking for the value closest to 0.95. Notice there's two that are equal distance. So what they do is they average 1.64 and 1.65 to get that value. Now, what you'll be happy to know if you're doing t critical values, man, they're way easier because they tell you here in the table. So let's say you want a 90%, and so 2 tail 0.10, right? Because that would be 90%, 1 minus that value. And then you look up the degrees of freedom, which remember is the sample size minus 1. So if you have a sample size of 10 and you're looking up a 90% critical value, then you just go straight across to 9 because that would be 10 minus 1. And so it's kind of nice that reading the t table is a lot easier to me than reading the actual z table, because the z you have to understand. You're getting that area down here at the bottom. And I think that's why a lot of times students, you still have to cut that in half, prefer the negative side, because then you only have to get the lower value and then just make it plus and minus. But hopefully that helps on understanding how to find critical value.